Okay, so today we are learning a bit more about the role of the moon in the solar system. So, the Earth, the Sun, and the moon, and the stars and other planets are all celestial bodies, and a celestial body is any natural object that is found in space. Many of these celestial bodies will orbit around another celestial body. And to orbit means to move around something in a curved or circular path. So you can see here all of the planets in our solar system, so the Earth and all of the other planets, orbit around the sun. So they follow these circular paths around the sun, which is in the middle here. So the Earth orbits around the sun, so the Earth goes around the sun, and the moon orbits around the Earth. So as you can see in this little animation here, we've got the Earth that is moving around the sun, and then the moon is orbiting around the Earth. So this animation is very, very sped up. The Earth does not spin that quickly. It normally takes 28 days for the moon to orbit once around the Earth. So it would take 28 days for the moon to go around the Earth once, and then it takes 365 days or a year for the Earth to orbit the sun. So the Earth isn't the only planet to have a moon. Other planets like Jupiter's have moons too. As we talked about last week when we were learning about light, the moon reflects light from the sun. So it doesn't produce its own light, it's only reflecting light from the sun. So the sun will produce light and some of it will arrive straight on the earth. So if it's daytime, we will have light that's going straight from the sun to the earth. If it's nighttime, though, we will have light that goes from the sun, lands on the moon, and then reflects or bounces off the moon. And that's why we can see the moon at nighttime, because the light from the sun is reflecting off of the moon. So, you will probably have noticed that the moon doesn't always look the same throughout the month. It kind of looks like it's changing shape, but it isn't actually changing shape. We just can see different amounts of it based on where the moon is and where the earth is and where the sun is at different times of the month. So at the start, we will have so when we've got a new moon, we can't see that. We can barely see it at all because the light from the sun is landing on this side of the moon. And if you think about us being on Earth here, we can't see any of it, right? Because we can't see this dark part here. So that part is not lit up by the sun. So it seems like the moon is very, very small, or we can barely see it at all. And then throughout the month, as the moon moves around the Earth, we will start to be able to see more and more of it. And here we can see that the light from the sun is going to reflect off all of this half of the moon, and so we can see what looks like a full moon from the Earth, and then towards the second half it will start to disappear again. So the moon isn't actually changing shape, we can only just see slightly smaller parts of it or larger parts of it at different times of the month. And you can see that here. So you can kind of see in this picture, the whole moon is still there, but we can only just see a very small part of it that's being lit up by the sun. To make things even more complicated, the moon doesn't always look the same based on where you are in the world. So if you are in the southern hemisphere, so the south half of the earth, so for example, if you're in Australia or maybe even Brazil or Argentina, the moon would look different at different times of the month. So this is how we see the moon in the northern hemisphere. So in England, for example, this is how we see the moon. And then in the southern hemisphere, their moon kind of goes the other way. So you can see it starts from this side, and then you can see the full moon, and then disappears from this side.